SIL-MORE Semiconductor Materials Application Solutions. In response to the stringent challenges posed by new generation high-power chip materials, SIL-MORE offers a variety of application materials. For chip protection, SIL-MORE recommends using SIL-MORE encapsulant. This material is a two-part, clear, heat-cure product that cures to either an elastomer or a gel, depending on the mix ratio, and offers good flowability. SIL-MORE is designed to meet the key criteria for the micro and optoelectronic packaging industry, including excellent adhesion, high purity, moisture resistance, and thermal and electrical stability. With its low Young's modulus, these materials can absorb the stress caused by CTE mismatches inside the package, thereby protecting the chip and the bonding wires. For semi-sintering silver material applications, SIL-MORE recommends using PROTAVIC ACH35006 semi-sintering silver. This is a one-component material with a viscosity of 15,000 CPS and a thermal conductivity of 20 W/mK. It is electrically conductive and specifically designed for chip packaging that requires high thermal conductivity and good electrical conductivity, such as power devices and LEDs. Notably, this material uses a solvent-free system to avoid voids during the curing process. It also offers good processability. Additionally, SIL-MORE can provide a variety of PROTAVIC silver adhesives required for semiconductor applications. For fully sintered silver material applications, SIL-MORE recommends using Nano top-low temperature, pressureless sintering silver material. This material cures at a lower temperature and does not require a pressurized process. It has a viscosity of 12,000 CPS and a thermal conductivity of up to 260 W/mK. The material uses a resin-free system, significantly reducing porosity to below 3%, making it the preferred material for next-generation ultra-high-power chips. For MEMS chip material applications, SIL-MORE recommends SIL-MORE encapsulant as a gold wire protection material. This is a one-part, dark gray, heat-cure material with controlled thixotropy, allowing it to flow as dispensed, and it features self-priming adhesion. It is ideal for applications where a semiconductor die has been wire bonded to a flat surface. Similarly, for MEMS packaging protection, SIL-MORE encapsulant can also be used to provide high reliability for the MEMS chip. For die attachment, SIL-MORE recommends using SIL-MORE adhesive. This material is a one-part, black, flowable, high-strength adhesive with self-priming adhesion. ME1070 is designed to meet key criteria in the micro and optoelectronic packaging industry, including high purity, moisture resistance, and thermal and electrical stability. The adhesive provides outstanding stress relief and high temperature stability, with excellent primerless adhesion to a wide range of substrate materials and components. It is ideally suited for microelectronic devices requiring low modulus materials, lead-free solder reflow temperatures, 260 degrees Celsius, or other high reliability applications. If a lower viscosity is required, SIL-7920 LV adhesive can also be used. It is suitable for microelectronics applications requiring good adhesion and reliability. SIL-MORE supplies these as convenient, one-part materials with specific formulations developed for electrical conductivity, electrical insulation, or thermal conductivity, all of which cure via heat without byproducts. HHCK 6635 underfill material involves first applying the adhesive to the solder joints before heating to fix it. Unlike traditional underfill methods, this approach helps avoid excessive voids during the flow process, which can lead to swelling after heating. Additionally, HHCK 6635 underfill has curing conditions that match the reflow process, thus eliminating an additional curing step. In TIM2 material solutions, SIL-MORE offers a range of materials with different thermal conductivities. For high-power thermal management materials, we recommend using SIL-TC 7006 gum. This material boasts a thermal conductivity of up to 7 W/mK, requires no additional curing process, and features low VOC and reworkable properties. Additionally, for non-silicone thermal conductivity materials, AOS 52050 can be selected. It has a thermal conductivity of 3.8 W/mK and is also suitable for TIM2 thermal management designs. In TIM 1.5 material solutions, SIL thermal gel series products can also be used. They offer a thermal conductivity of 7 W/mK, a dielectric strength of 8 kV/mm, a volume resistivity of 2.0 times 10 to the power of 13 ohm *cm, and a bondline thickness, BLT, of approximately less than 50 m. These characteristics make them the preferred choice for TIM 1.5 applications. In SMT stencil flux cleaner material solutions, we recommend using Kaizen series products, such as CyberSolve C8882. This product effectively removes various types of fluxes and dries quickly after cleaning. It is compatible with most automated stencil printing equipment and can also clean uncured chip attach adhesives. Micronox MX2322 is suitable for immersion cleaning systems and effectively removes residues from all types of fluxes. It offers broader applicability and longer cleaning life and can be used in conjunction with wafer cleaning or ultrasonic cleaning equipment. SIL-MORE provides a one-stop complete material solution for semiconductor chips, MEMS, TIM, and SMT stencils, meeting the needs for next-generation high-power materials. If you would like to learn more about SIL-MORE's semiconductor material solutions, please feel free to contact us. Thank you.